Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and we're ready to have some fun. Now, a little while ago, Professor Dave Explains put out 10 challenges for the flat Earth. And one of the flat Earth actually came forth and ventured some answers. And I looked at his video, it's an hour and a half long, and it was just a hoot. So what I'm going to do is I'm going to go through his answers one at a time. Now, if you're interested in seeing who did this, there's the link right there. I'm not going to be giving additional attention and oxygen to the flat Earth, but I will have the link to Professor Dave Explains' original video down in the description. My wife just brought me a whole thing of jelly beans, and I'm ready to get going. So let's cue up the music and have some fun. So let's just jump right in. Dave's first challenge is make a real map of the flat Earth. And in order to be a real map, it has to have a scale that you can measure distances between any 2 points on that map, and those distances have to equal the known distances between those 2 points. Now, before we get started with this, I'm just going to set up a certain rule, and that is you have to answer the question. You don't get to answer a question with a question. So for example, the question is, make a real map of the flat Earth. That does not involve saying how the globe doesn't work. That involves you getting out a sheet of paper and making me a map of the flat Earth. One that has a scale on it. One that I can measure distances accurately between any 2 points of my choosing. And those distances will equal the known distance between those 2 points. Now, I don't have high hope that you're going to answer this question directly, but I'll try and hold your feet to the fire a little bit and make you answer it. And then I'm going to point out when you don't.
I find that flat maps correlate quite well with reality. Globes, not so much. Google Earth, for example, when you zoom into the view where you can actually see real things, not computer-generated shapes and things like that, it's flat.
Well, 2 things here. First of all, are you saying Google Earth is your flat Earth map? Nathan and Quantum Eraser tried that once and had their tail ends handed to them by yours truly. So you're going to have to do a little bit better. You're also going to have to overcome the fact that when you're dealing with a very large sphere, and you look at a tiny postage stamp size section of that sphere, it does look pretty flat. But again, it does curve over distance. And that curve is easy to see. So I'm not going to buy this one. You have to show a flat Earth map that has accurate distances between 2 points. Keep going.
When you zoom to a level where you can measure from point A to point B, it's flat. If you take any aerial photographs at all over the world, and you piece them together, splice them together to fit perfectly, if they fit perfectly, the photographs are flat.
Except, of course, they don't. And anybody that has ever tried to piece 2 large maps together knows that. For example, aviation sectional maps are Mercator projections. They're a little wider on the south side than they are on the north side here in the United States. So if you try and put 2 of those maps together, the top of one map will not match up to the sectional map above it. There will be an overlap because there's a little bit of distortion in them because they are flat maps made as a projection of our spherical Earth. It simply doesn't work. So either this is an outright lie or he's never actually tried it. Since the people that watch this video are intellectually honest, they can get 2 maps and try this. And you'll see that they don't match up perfectly.
The corners match up perfectly, and you get a map much like what you have shown. The fact that circumnavigating goes in a circle never happens in a verifiable way, and rarely is ever claimed to happen north-south.
Well, as with most flat Earth claims, this is nothing but personal incredulity and no research. For example, here's Magellan's circumnavigation of the Earth, the first one recorded. Let's go see if we have any others. Oh, look at that, from a flat Earth organization. 4 documented round-the-world circumpolar flights. Now, Pan Am Flight 50 is very well documented. As a matter of fact, there's a YouTube video on it, and I'll see if I can link that in the description. But are there any others? How about the latest one, One Last Orbit? That was a circumpolar navigation of the Earth. It went over the North Pole here and the South Pole down here. It was GPS tracked the entire time, and it is a documented world record. Well, there you go. It's around the world in 108 nights. It'll run you $17,299. How many tickets would you like, Chief? And what's more, you can bring a sextant if you know how to use one, and a GPS, and document the entire trip. Why don't you go ahead and do it for Flat Earth Science?
Like, how many people do you know who have been around the world did it east-west, like a circle, like what we are saying?
Chief, I would be rather surprised if you personally knew anyone that has been around the world. Now, I've known people that have come close in my own family, and then I know people like Wolfie6020 that have done it probably a number of times. Wolfie does long-distance flights from Australia to Europe all the time. He also goes to Asia. I'm sure that he's completed the chain at one point in his career.
Not one of them has ever done the north-south way around. Not over the southern part. It's very much like an outer ring. And when you splice together the photos, yeah, it more closely matches that.
But for those with an even smaller fraction, let's do a few things to prove it. For example, make a scale. You know, a scale? It's that thing on maps that tells you how far away things are from each other.
The condescension to think that we are at a level that we haven't even gotten through the formative years of education, like grade school.
Well, actually, that's a very legitimate question, because most of us learn the shape of the Earth and how to determine it in grade school. You apparently missed that day. He's asking you a very specific question. Put a scale on the map that allows you to accurately measure distances. Why is it that you don't have a flat Earth map that you can measure the distance from the shore to oil rigs off the coast of California, or the distance between two mountaintops that we shouldn't be able to see, or the distance between the Warren Dunes and the Willis Tower in Chicago? So why is it you always have to use a satellite and globe-based measuring device such as Google Earth to find those distances? Where's your flat Earth map where you can accurately measure that distance for yourself?
And it also is insulting, it's belittling. I think it would demand an apology.
I just want to address two quick things about this photograph. First of all, it's J. Tolan Media One. I've dealt with a number of his videos in the past, and quite frankly, he's got all sorts of things marked here as landmarks, but he can't identify even basic landmarks. He identified a cloud bank as Hudson Bay. The other thing that I really want to bring to your attention, so you know how Flat Earth is always saying that composite pictures are CGI and therefore of no value? Do you see this seam right here? This is a composite picture. Does that mean that we should just hand wave it off? Or is that a picture of a real landscape? I'll let you decide that.
You don't think that we have the intellectual capability to even discuss these basic things when, in fact, these types of things we got through in such early stages of research, like seconds. The distance behind you are in discovery is astounding. It really is astounding.
Well, a couple of things that you should be aware of there, Chief. You're no more likely to get an apology from Dave than you are to get one from me. And yes, we do realize that you have absolutely no idea what you're talking about, and that's verifiable. Here, I'll prove it to you right now. Why don't you go ahead and give me an accurate flight plan between Santiago, Chile and Sydney, Australia. Tell me exactly how far that's going to be, how long it will take you to fly it, assuming no winds, at 550 knots, and why don't you go ahead and give me reporting points every 500 miles along the way. This is a challenge that Wolfie's had out for quite some time, and nobody to date in the Flat Earth has been able to accurately do a flight plan like that. Let's see if you can do it, since you're so smart. Now, another thing that I want to get back to, the question is, where is your flat Earth map? Is this your flat Earth map? Can I measure distances between those 2 points on your flat Earth map? Where's the scale on your flat Earth map? What is the distance between the tip of South America and Tasmania up here? And if I wanted to fly in a straight line between them, would I go over land or water?
Look at this map. There's a scale. You can pick 2 cities and determine the approximate distance between them. Then you can drive your car from one to another and verify that it is the correct distance.
I agree. Would you agree that that map is flat?
Okay, so your claim is because that map that Dave was using is a projection of the globe onto a flat piece of paper. That's your flat map? Can you make one map like that is accurate, not just on a short distance, say over the United States, but over the entire Earth? So is that going to be your flat map? Well, then you automatically lose this question because that map is the projection of a globe onto a flat surface with distortions due to the fact it is a projection of a globe onto a flat surface. Do you know how maps are made, Chief?
Now back to your little map. Where's the scale here? Why do you never include one? Is it because it's impossible? Yes, that is exactly why. And if you disagree, here's your challenge. Pick some distance on this map, a centimeter, an inch, whatever. Tell me the distance it corresponds to in reality. Then pick some cities and use your scale to estimate the distances between them. Pick 2 on the same continent. Pick 2 on different continents. Use it to tell me how wide this inappropriately enormous ocean is. Use it to tell me literally anything about the distances between literally anything.
These are aerial photos, not from a satellite. They're high altitude flight photographs made from the air. And splice them together, and we can do all of those things.
Well, first of all, that's a satellite photo. It's not from the air. Do you have any idea how high that photograph is taken from?
Now, where would it be a problem? Where would it really show that it's matching our map versus yours? In the northern latitudes, not so much.
Now, you see right here, you're starting to really go off the rails. What you're looking at is a relatively small area of the overall Earth. Your job, my friend, is to show me a map of the entire flat Earth that is accurate to scale and shape. Show me a flat map of the entire flat Earth. That's your job.
But in the southern latitudes, where the scale issue would become more apparent, you get to a point where the oceans, they can't make up for the stretching, okay? We'll talk about stretching in a minute. The verifiability of the comparison between the southern latitudes and the northern latitudes becomes more divergent.
Well, it absolutely does not. And I'll tell you why. First of all, we can locate all points on the south. It's not a problem. We have GPS, we have sextants, we used to have Loran. We know the distance between, say, Sydney and Santiago, Chile. We can sail a ship between those 2 points. We know how fast the ship goes. We can measure the speed of the ship and see how long it takes to get there. We can also check to see how much fuel it takes as another indirect measurement of how far it is. We can do the same thing with airplanes. Airplane service is regularly scheduled between Australia and South America, between Australia and South Africa. We can actually time these things, and we know how fast the airplanes go. So to try and say that somehow we're fudging the distances is ridiculous. It shows how little you actually research this. Why don't you go ahead and look into some of these flight schedules? Do your own research. Don't raise questions, find answers.
Terrain spawn. Whereas in the north, there's actual verifiable stuff like you mentioned. So, okay, challenge met.
When you can't do it and your numbers do not correlate with reality in the slightest, recall that this map does it just fine, and then admit that your map is stupid.
Actually, Google Earth and the related aviation products that use spherical geometry for navigation do it exactly right every single time, thousands of times every day. You claiming that they don't work doesn't mean that they don't work. Those of us that actually use them know they work, and they're reliable, and they're accurate. So that's a fail for you. Look at Google Earth. It's spherical. Look at the aviation maps. They're spherical. It's spherical geometry that we use for navigation. That's why the shortest distance between any 2 points on Earth is a great circle course. It's not a line like you try to draw on your flat Earth maps. When you do that, you don't follow the course that the airplane would follow. That's why it mystifies you when planes going from Taiwan to Los Angeles make emergency stops in Alaska, because you can't figure that out. And you refuse to ask anybody who does actually know what's going on. How many times have those of us in aviation put the correct answer out there only to have it ignored by you because it doesn't follow your silly flat Earth narrative?
Match up with the distances because it's flat. That's why it works. If it were curved, it wouldn't work so well. You can say, well, it matches with the lines and everything like that. But again, how could that work if it's actually curved in reality? So the reality doesn't match the map where you do the lines and everything works out?
You know, this is one of those times that you have to just sit down and go, you know, this is the same argument that you make with fisheye lenses. Fisheye lenses give you more information coming in. If you know that it's a fisheye lens, you can actually make out what the fisheye lens is looking at very nicely. You can understand what it's seeing and why some objects that are straight appear to be curved and why some objects that are curved appear to be straight. The same thing with maps. We understand the distortions from projections of a globe onto a flat piece of paper. We can accommodate those things. Show us a flat Earth map of the entire Earth. Put a scale on it. Let us measure between 2 points of our choosing. That's your challenge? So far, all you have done is just wandered off and shown random slideshows. You have yet to produce a flat Earth map for us. Are you going to try? Now, once again, because you apparently are a little hard of hearing, we're not talking about the globe. We're not talking about maps made from projections of the globe. We're talking about you coming up with a flat Earth map that covers the entire Earth that has a usable scale on it. Do you have one?
If the disparity is in the model, in the problem of the globe model being artificial, being different from reality, then there are experiments we can do to verify why.
Well, funny you should mention that, Chief, because I put one out yesterday. J. Tolan Media One's observation of Mount San Jacinto from Malibu, California, 123 miles, over 4,000 feet of missing mountain due to Earth curvature. There you go.
If isn't a question for me, it's a question for you. The if part is simple, and it's in one of your later challenges, so it will support this point. But I just wanted to follow up with what I mentioned about the curve, because the map that you showed as an example, not only did it have several different scales, like Alaska being shrunk down, and it's very convenient. But if you would blow up Alaska, blow up Hawaii, put them relatively where they need to go on that map, that flat map, then you have stretching. You have different problems of scale that rarely get addressed. So if it works on the flat map, then how could it be curved?
Your complete inability to make any kind of remotely legitimate map single-handedly proves the Earth isn't flat.
And there you have it, folks. Despite being given an opportunity and very clear instructions, Mr. Flat Earth had nothing but personal incredulity. He wandered all over the place with random slideshows and random thoughts that went into his disorganized brain and came out his mouth. No attempt to actually come up with an actual flat Earth map, one that could possibly account for accurate distances between known points on the Earth. There was a shocking lack of research into circumnavigation of the Earth. I showed the historical circumnavigation, I showed recent ones, including one from just last year, and I even showed him how he could buy a ticket to do one and how much it cost. Will he take up that offer and go do it himself with a sextant and a GPS? Of course not, because that would disprove his silly narrative. Now, the biggest problem that you run into with the flat Earth is they will never present evidence in support of their flat Earth, because any evidence they support could potentially be falsifiable. What instead, whenever you ask them a question, is they will redirect that to another question. Well, what about this on the globe? I don't care about this on the globe. Let's make it easy. Let's say the Earth isn't a globe. Prove to me it's flat. Start with a map. You can't even do that. And as Dave says, that means the contest is really over. But for nothing more than my personal amusement and the amusement of my viewers, I'm going to let you struggle through the other 9. This is Bob the Science Guy signing out from Northern Michigan, and we'll see you next Tuesday with the next installment on Antarctica. Until then, take care, hit that like and subscribe button down there, and we'll see you soon.